to Educator.com. In today's lesson, we're going to be working on multiplying polynomials. We're going to be using the distributive property in order to multiply two polynomials. In the past, we applied this rule to multiply a monomial by the polynomials. Well, we're going to do the same thing, the same basic concept here, except applying it to more complex expressions. Remember that the distributive property says a times b plus c equals ab plus ac. And again, it also applies to longer terms, longer expressions such as this one, to give you ab plus ac plus ad. So the same underlying technique or property applies. Thinking about applying this to the multiplication of two polynomials, you could have an expression such as 2x squared plus 5 being multiplied by, so it's a binomial, being multiplied by this trinomial. So using the distributive property, we've worked with monomials where we would just have one term out here and multiply it by each inside the parentheses. Now we do the same thing but with each term. I'm going to multiply 2x squared by each of these, and then I'm going to go back and do the same thing with 5, multiply it by each monomial in here. Okay, so starting with the 2x squared, multiplying that by the first term, x squared, plus 2x squared times 4x, 2x squared times negative 4. So the distributive property as usual, it's just we're doing it twice. We're doing it with each of these. So now I'm going to take my 5. So plus 5 times x squared plus 5 times 4x plus 5 times negative 4. Once I get to this point, then I just go about, as usual, multiplying each of these monomial by monomial and then adding like terms in order to simplify. So it's just that first step that you need to get used to, where you're not just multiplying one term by the terms inside the parentheses, but you're doing it for each term out here. When multiplying binomials, there's a method called the FOIL method that helps you to remember to use each term. So if you're multiplying two binomials, you'll have something like this, 4x plus 2 times x minus 5. Well, the distributive property tells me that I need to multiply 4x times x, 4x times negative 5, and then I need to go back and do 2 times x and 2 times negative 5. Well, FOIL method helps me to remember exactly how to do that so that no terms are left out and I can just do it quickly. FOIL stands for first terms, so multiply the first terms, multiply the outer, so the first term is 4x and x, then the outer terms, the outer two terms, the inner terms, and then the last terms. You're really just using the distributive property, but this is a way to help you remember that. So using the FOIL method, let's rewrite this right here. Okay, what I have is the first term. So 4x and x are the first term. So I'm going to multiply those two. 4x times x. Then, according to FOIL, I'm going to multiply the outer terms. So these are the outer terms. That's 4x times negative 5. Then I'm going to multiply the inner terms. So the inner terms are 2 and x. And finally, I'm going to multiply the last terms, 2 and negative 5. Okay, so first terms, then the outer terms, the inner terms, and finally the last terms. And that covers every combination according to the distributive property. So I work this out and it becomes 4x squared minus 20x plus 2x minus 10. I'm not quite done yet because I know that I need to combine like terms. Negative 20x plus 2x, that's negative 18x minus 10. Okay, so the FOIL method can be applied to multiplying two binomials. In this first example, that's just what we have, two binomials. 2x minus 3 times 4x plus 7. So I'm going to use the FOIL method. I'm going to multiply the first terms. That's 2x times 4x. Then I'm going to multiply the outer terms. That's 2x times 7. The inner terms. So I had my first terms, my outer, my inner terms. The inner terms are negative 3 times 4x. And then finally the last terms, which is negative 3 and 7. Then I go ahead and I multiply. So this gives me 8x squared. That gives me 8x squared plus 14x minus 12x minus 21. But I'm not quite done yet because I have some like terms. So I combine 14x and negative 12x, and that's going to give me 2x. So my final answer is going to be 8x squared plus 2x minus 21. And what I did is I applied the FOIL method, multiplying the first terms, then the outer terms, inner terms, and finally the last terms, and then simplifying as usual. Example 3. Again, I have two binomials, so I'm going to use FOIL. And just to remind you, this stands for first, outer, inner, and last as a method of remembering which terms to multiply and making sure that all combinations are used. My first terms, 8p times 9p, the first terms. Outer terms, 8p times 6q. Inner terms, and finally, last terms, these two. Multiplying these out, 8p times 9p is 72p squared, plus 8p times 6q, that's 48pq. Negative 7q times 9p is negative 63pq. And then negative 7q, negative 7q times 6q is going to give me negative 42q squared. Adding the two like terms I have here to further simplify this is going to give me 72p squared minus 15pq minus 42q squared. Again, we recognize that we have two binomials. It's multiplying binomials. So using the FOIL method, first terms multiply plus the outer terms being multiplied plus the inner terms plus the last terms. Multiply it all out, simplify, and this is the answer when you multiply those two binomials. Example 3. This one's more complicated, and we can't use FOIL because this is not a binomial times a binomial. Instead, it's a binomial times a trinomial. So instead, I'm just going to recall the distributive property, make sure that I multiply out everything that I need to using the general distributive property. A times B plus C equals A times B plus A times C. And I actually have 2 terms out here and 3 in here, but that's fine. It's still the same principle. So I just have to be careful and make sure that I catch all of these terms. First, I have 3s. I'm going to multiply it by each term in here. 3s times 8s squared plus 3s times negative 6st plus 3s times 7t squared. Okay, I've taken care of the 3s. Now 4t times each of these. Negative 4t times 8s squared plus negative 4t times negative 6st plus negative 4t times 7t squared. Okay, so now I've got everything multiplied out. Now I'm going to multiply the monomials times the monomials, and this is going to give me 24s cubed. 3 times negative 6, that's negative 18s squared t plus 21s t squared minus negative 4, so it's negative 4 times 8, so that's minus 32s squared t. Negative 4 times negative 6, that's going to become a positive 24s t squared. Negative 4 times 7, negative 28t cubed. Okay, now I have some like terms, so I can do some simplification. Looking through, I have only one s cubed term, so that's just going to become 24s cubed. And I'm going to group like terms so I make sure that I don't miss anything. Next, I have a negative 18s squared t right here. So I look and I have another s squared t term. Okay, so I've taken care of this, this, and this. Next, I have a term that has as its base st squared. And I have another like term, 24st squared. Finally, I have negative 28t cubed. And you can double check by saying I have 1, 2, 3, 4, 5, 6 terms here, 1, 2, 3, 4, 5, 6 terms here, so everything's accounted for. Then it's just a matter of adding everything up. And it's 24s cubed minus 18 and negative 32 comes out to negative 50s squared t. 21 and 24 is 45st squared minus 28t cubed. Okay, so I had a fairly complicated situation here, multiplying a binomial by a trinomial, and I handled that by multiplying this first term 3s times everything in the parentheses. Then the second term, negative 4t, by everything in the parentheses. That gave me all of this. I multiplied them out, grouped like terms, which I had a couple, and then added to give me the answer to when this is multiplied out. Now in example 4, I have a trinomial multiplied by a trinomial. So again, I'm going to handle that using the distributive property, which is going to tell me that I'm going to take the term on the outside of the parentheses and multiply it by each term inside. Now, you can certainly write each step out as I have been doing, the 2y squared times 3y squared, but as you get more proficient at these, you can also just multiply them and then write the answer for that. Multiply the two monomials directly and write that down to just move more quickly and efficiently when you're ready to do that. So let's try it that way. If I have this first term, 2y squared times 3y squared, 2 times 3 is 6, 2 plus 2, that gives me 6y to the 4th. Again, if you need to write out 2y squared times 3y squared, do that step. Eventually, you'll do it this way, though. Then I have 2y squared times 5y. 2 times 5 is 10. Y squared and y gives me y cubed. 2y squared times negative 6 is negative 12y squared. Okay, that took care of this. Now I'm on to negative 3y. Negative 3y times 3y squared is negative 9y cubed. Negative 3y times 5y is a negative 15y squared. Negative 3y times negative 6 plus 18y. Took care of that. Now 7. 7 times 3y squared is 21y squared. 7 times 5y is 35y. 7 times negative 6 is negative 42. Now, how do I know that I've taken care of everything, especially since I'm just doing a little more quickly and not writing out that entire step? Well, if I need to multiply 3 things times 3 things, 3 terms times 3 terms, that's 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a good double check. Once I've gotten to this step, I just need to add the like terms, starting out with 6y to the 4th. And I see I don't have any other terms like that, so it's simply 6y to the 4th. I have 10y to the 3rd, and I have negative 9y to the 3rd. That gives me y to the 3rd. Okay? Now I have a negative 12y squared, and I have a negative 15y squared, and I have 21y squared. So I have 3 terms with y squared. And these add up to give me negative 6y squared. Okay, so I took care of my y to the 4th, my y cubed, my y squared. Now I have y. 18y plus 35y adds up to 53y. And finally I have a constant. So multiplying out 2 trinomials will give me 9 terms, which I need to simplify a little bit more by adding like terms to come up with this expression. Thanks for watching Educator.com, and I'll see you soon.